Welcome back. Our second lesson on probability is expectation. For this lesson, we're going to need to be able to times fractions by integers. So this is your starter. If you know what you're doing, pause the video now, choose bronze, silver or gold and have a go at those. If you want an example, there's going to be one on the next slide. So remember, when multiplying fractions, we're going to times the numerators times the denominators. But when we have an integer, it doesn't have a numerator and a denominator, it's just one number. So the way we can change it into having a numerator and a denominator, so turning it into a fraction, is by putting it over 1, like this. 16 over 1 is the same as 16 divided by 1, which is 16. So I haven't changed the value, it's still exactly the same. So then I would proceed by timesing the numerators, 1 times 16, timesing the denominators, 4 times 1, and we'd get 16 over 4. Can I simplify that? Well, I could divide by 2, and I can divide both the top and bottom by 2 again, 4 over 1, so that's going to be 4 in total. Let's just look at one more example. 66, well, to make that a fraction, remember we can put it over 1, that's 66 divided by 1, it's not changed the size. Instead of having to do big calculus, so 66 times 2, let's see if I can cancel anything. So remember, you can cross cancel. What does that mean? Well, anything on the top you can cancel with something on the bottom. Well, the 2 and the 3 don't cancel, but 3 and 66, 3 goes into 3 one time, and 3 lots of 22 go into 66. So I can cancel that there, making it easier. So 22 times 2 is 44. 1 times 1 is 1, so my answer is 44. If I hadn't cancelled, remember I would have done 66 times 2 on the top, 1 times 3 on the bottom. That would have given me 132 over 3, and then I would have had to divide that. So it just helps us when cancelling. It means we don't have to cancel much at the end if we can do it nearer the start. So if you watched the examples, now have a go at the questions. If you're now looking for the answers, go to the next slide. Here are your answers. Make sure to mark them off. So we're going to look at our expectation today. Remember this red box here, probability equals wanted outcome over the total number of outcomes. Firstly, we're just going to have a look at this scenario. We've got a snail race here. A snail can move forward if their number is rolled on the 2 dice. So for example, if it rolled a 1 and a 1, that's 2 in total. So this snail here would move 1 forward. Have a think now. Who would you expect to win the race? Snail 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Which one would you think would win, and why do you think that? We're going to have a look at now at one possible race that could happen, so just watch this video. So the winner of our race was this snail here, snail 7. So if you rolled a 7, that snail would move forward, and that's the one that won. Is it a coincidence that the middle numbers, so that 6, 7 and 8, were thrown the most number of times? Well, no, it wasn't a coincidence. They're more likely to throw a 6, 7 and an 8, because let's think about it. How many ways are there to roll a 7 with 2 dice? Well, you could have a 4 and a 3, a 2 and a 5, or a 1 and a 6. So there's 3 different ways you could roll a 7 when you have 2 dice. What about, let's say, ways to roll a 2? Why was 2 a lot less than, let's say, 7? Well, there's only one possibility to get a 2, a 1 and a 1. So we've got to think about how many different possibilities there are. with 7, there was 3 different possibilities, so we would expect an outcome of 7 to happen a lot of times. Whereas with 2, you can only get a 1 and a 1. So when we had a look at the snail race, we would expect 2 to not do very well. We could say for sure at the start that 1 wouldn't move ever because it's impossible to roll a 1 with 2 dice. By the end of the lesson, we'll be able to answer something like this. The probability of picking a red marble is 0.15. How many times would you expect to pick out a red if you picked a marble out 50 times? So let's have a look at this example here, one that maybe we know how to do already. Jim flips a coin 50 times. How many times would we expect him to flip a heads? Well, if it's a fair coin, it's got equal chance of landing heads or tails. So if you're flipping it 50 times, I'd expect 25 heads and 25 tails. Well, that example there, I just sort of have seen a lot before that I know how to do it, but what have I actually done? We would expect it to be 25 of heads, 25 tails, but realistically, when we do it, we may get maybe 22 heads and 28 tails. It's not always going to end up like that, but we know the rough number is going to be about 25. How have we got to 25? We've used this formula here. Our expected outcome equals the probability of the event times the number of trials. Number of trials just means how many times did we do the event? How many times did the event happen? So we know that the expected outcome for this, the probability of the event, well, the probability of flipping a head is 1 out of 2. 1 head out of a possible of heads or tails, 2 things. So a half, times by the number of trials, so times by 50, because we flipped it 50 times. And just like we've seen before, putting a 1 over the 50 so that we can have 1 times 50 on the top, 2 times 1 on the bottom. 50 divided by 2 gives me 25 times. So we'd expect 25 heads. So for this lesson here, this blue equation is really important. It's what we're going to be using throughout. I roll a dice 60 times, so we're now looking at a dice. How many times would you expect to roll a 1 or a 2? So expect, remember expected outcome, it says at the bottom, is the probability of the event. Well, the event I want is to roll a 1 or 2, times by the number of trials, so how many times I do it. So first of all, let's have a look at the probability. The probability of rolling a 1 or a 2 is, well, let's think about a dice. We've got 1, 2, 3, 4, 5, or a 6. A 1 or a 2. Well, that's 2 different numbers I could have out of a total of 6. So I could say that's 1/3. So I say again, expectation is the probability, which I've just worked out to be a third, times by the number of trials. So that's how many times I did it. So that's the 60 here. Using the fact we could put a 1 over there, that's 1 times 60 for the top, 3 times 1 for the denominator. 60 divided by 3 gives me 20. So if I were to roll a dice 60 times, I would expect 20 of those times for it to land on a 1 or a 2. Your turn now. Have a look at the right-hand side. Have a go at that question. Okay, so remember again, expectation is the probability. This time we're looking for it to be 4 or below, and times by the number of trials, how many times we did it. Let's first of all have a look at the probability. Probability of 4 or below. Well, on the regular dice, we have 1, 2, 3, 4, 5, or 6. 4 or below, it could be 4, 3, 2, or 1. So that's 4 different numbers it could be out of a total of 6. So that's the same as 2/3. So going back to expectation, our formula, probability times by the number of trials, where we did it 60 times, and now we've just got to do that calculation. 2 times 60 is 120, 3 times 1 is 3, so that simplifies to 40. So if we rolled a dice 60 times, we'd expect it to be 4 or below 40 times. It may not be exactly 40 if we actually did the experiment, but we'd guess the number would be around that. Another example, but with a different scenario. So let's have a look. Part I, I've got a spinner. All the different sections are the same size, so you'd have an equal probability of landing on the 1 as, let's say, the 2. The spinner is spun 80 times. How many times would I expect it to land on the yellow? Well, I would expect it to be, so expectation is the probability of yellow times by the number of trials. Well, the probability of yellow, it could either land on the 2 or the 3. So that's 2 different spaces it could land on, and there's 8 in total. And I've got to times that by the number of trials. So that comes out as 160 over 8. What is 160 divided by 8? Well, I know 16 divided by 8 is 2, but I've got 160, so that's going to be 10 times bigger, so 20. Second part, what would I expect for red? Well, I've got to find the probability of it landing on red times by the number of times we spin it. Probability of red, well, there's one shape on the red out of 8 in total, and the number of trials is 80. So what's 1/8 of 80? Well, timesing it, we've got 80 divided by 8, which gives us 10. Last one. What's the expectation of landing on a yellow 2? Well, the probability of yellow 2, it has to be both of them, doesn't it? So there's only one space on that spinner, which is both yellow and a 2. So the probability of yellow 2 is 1/8 times by the number of trials. So that's also going to give us 10. So that makes sense, doesn't it? There's the same probability of it landing on red, because that's just one section of the spinner. That's the same expectation as if we wanted it to land on the 2 there. Have a go at these questions on the right now. So for part I with blue, the probability of it landing on blue is 3 out of 8, because there's 3 squares, and we have to times by the number of trials, times by 80. If you're doing those cross-cancelling, you can notice both 8 and 80 go into 8. There's 1/8 in 80, there's 10/8 in 80. So 3 times 10 is 30, divided by 1, you should get 30 for the first one. Probability of it landing on purple, well, there's 2 squares out of 8, or 2 sections out of 8, times by the number of trials, so 160 over 8, which you should have got 20. Last one, what about purple 8? Well, there's only one section with purple 8, times by the number of trials, 80 there, so 1/8 of 80 again is 10. So those should be your 3 answers there. Okay, you've got 4 questions here to have a go at, so pause the video, have a go at all 4 questions. Here are the answers for those. If you've got some wrong, just make sure you look over it. Did you get the probability right? And did you times it by the right thing? So have a look back at the equation. If you found those quite easy and want a bit of a challenge, here's some 4 exam questions to have a go at. So I'd really advise you to have a go at these 4 questions, because these are what the exam or test questions are more likely to look like. So give yourself 10 minutes for those 4 questions, and then we'll have a look at the answers. Here are the answers to those 4 questions. Notice every single time I answered it, I would write expected outcome equals the probability times the number of trials. Filled in the probability, filled in the number of trials, and then worked from there. For example, on this first question, if I had written this down, this would have gotten me a fair few marks, even if I got the end answer wrong. So it's really important to show your workings. Finally, you're going to have a go at this game here. So the link's up at the top. I'm going to attach that to show my homework. The aim of the game is to have the most money in your bank after 5 minutes of playing. So you're going to give yourself 5 minutes to play, and you're going to have a go at this game here. So what you have to do is, here's you here, and these are just the computer players who you'll be playing against. You're given a question like this. You roll 1 dice. If you do this 100 times, how many times would you expect that it's odd? So you've got to sort of think in your head, how many times do you reckon it will happen? Well, if we were actually to do the maths, a dice has 1, 2, 3, 4, 5, and 6. How many times would you expect it odd? Well, odd is 1, 3, 1, 3, or 5. That's 6. So that's 3 out of 6 numbers are odd, or a half of the numbers are odd. So if we threw it 100 times, we would expect it to be half the number of times. So my guess would be 50. And I'd click submit. Everyone else on the game also submits an answer. So maybe we have James going for 52. Lucy may go very low and 20. And then they'll do the experiment. And the person who's closest to what actually happens will win the money. Okay? And you'll give 5 minutes, and then you're going to submit your score to me. I'll show my homework with a photo showing your bank balance, and the top 3 people will gain lockdown points. So have a go at that game at the end.